All right, so we weren't able to type that in, okay, but I'm just gonna go ahead and do real quick. So like I said, we had 8.04 divided by, what was that number? 6.02, okay. And then we should have got 8.04 divided by 6.02, and that gives us what? That gives us 1.335, okay. Let's just write out 1.335. In this case, I'm going to round this number right here. So that means this turns into 1.34, rounds up because it's a 5 or more. Okay. And then this turns into moles. Whoa, come on, buddy. Moles. Man, that was not good. Let me make that a little prettier. Okay. So let's see. So that turned into, whoops, meet that guy. All right, 1.34 moles of bromine. Okay. So don't forget that the reason why we did not worry about this 10 to the 23rd power, so these exponents, was because remember when we did the calculation, it was 23 minus 23, okay? And that turned into 0. And then when that happens, it's easy for us to say that it'll be 10 to the 0, right? Because now that 0 replaces this guy's right here. And then remember that is equal to 1, okay? So then that's why we don't include it in here, because it's 1. So we don't have to put that, all right? So this would be our final answer, okay? 1.34 times, 1.34 moles of bromine. Alrighty, so let's continue on. Let's see. Okay, so let's go into molecules of propane, okay? So now we're going to be doing it a little bit differently, okay? So first off is I need my, my scribble pen, but we should be good now, okay? So the conversion factor, so just get accustomed to writing the conversion factor, all right? So remember we have 1 mole of, so now we're in propane, so we have to write propane. Okay, that's an E. Is equivalent to 6.02 times 10 to the 23. In this case, the question statement is asking for molecules. So now the units changed from atoms to molecules. All right, molecules of propane. All right, so this is kind of big. I know it stinks. 6.02 times 10 to the 23 molecules of propane. All right. And this is equivalent to 1 mole of propane. Okay, so I want you to know that this is, these are two separate conversion factors, all right? So here's one of them. I'm gonna circle it in black. That was supposed to be yellow, but I don't know why I didn't do yellow. Okay, so that's one of them. And then the other is, why doesn't the yellow one work? There it is. Okay, and then the second one is this guy right here, highlighted in yellow, all right? Don't want to confuse you guys, all right? So there's 2 of them. The reason why it's so big is because of having to write all those words. What we could do is we could write propane in its chemical formula. If we do that, we see that propane is C3H8. So we could replace that in here. So we could say propane. Well, let me get my black marker again. Boom. So we can say propane is C3H8. All right. Propane we can say is C3H8. So First thing we do is we realize that we're trying to, first off, let's go back into solving the problem. We notice that we want to go from moles to molecules. All right, so in order for us to do that, we're going to write down what's given first. So we're going to write down 2.12 moles of propane, C3H8. Okay, we write that over 1, same thing like usual. We're going to multiply that by our conversion factor. Now we want molecules on top. Okay, we want to write molecules on top. So in order for us to do that, we have to use the conversion factor with molecules on top. So in that case, we want to use this guy. Okay, so then we're going to write this conversion factor right over here, 6.02 times 10 to the 23 molecules of propane, remember C3H8, over the bottom portion of that was 1 mole of propane, C3H8. Okay, so if we did this right, our units should cancel, which, they do. Okay, so that means we're doing this right because here moles of propane cancel out with our moles of propane. Okay, remember, numerator and denominator, they both cancel. Okay, so simple thing here to do is we're going to take our numbers here and we're going to multiply them. Okay, so do not worry in this case. Okay, so whenever you see a number here, see how here we have just a simple regular number, and here we have the number in scientific notation. The way that we do this is the same way. What we could do is we could rewrite this. We could rewrite this as 2.12 times 10 to the 0 power, because that's essentially what this is. 2.12 times 10 to the 0 power. Okay, if we were to write this in scientific notation. So now we could do the multiplication even easier. Okay, so what we do here, let me get my black pen again. Oh, excuse me. So what we do here, same thing. We want to multiply, in this case, our coefficients. So then we're going to do 2.12 times 6.02. Okay, and then we're going to add our exponents. So here we have 0 plus 23, because they're the same exponent, or same base, so we can add the same numbers. So then that turns into times 10 to the 23, stays the same. Okay, so then what we can do now is we're going to put in our parenthesis here, and then we're going to multiply it by our 10 times 0 plus 23. Okay, so this is the correct way to set up our equation. Okay, and then we can't forget our mole of propane, C3H8. Okay, so we get our trusty calculator and we write 2.12 times 6.02. And that gives us 12.76. All right, so we could write now 12.76 times 10 to the 23rd power, because 0 plus 23 is still 23. Okay, but now we have to make this into the correct scientific notation. So we're going to move the decimal place 1 more, which means we have to add 1 more 10. So if I do that, this turns into 1.276 times 10 to the 24th power. All right? And this is still mole of propane, C3H8. All right? And then I'm going to let you guys tackle example 5. All right? I want you guys to be able to try this on your own as well. Okay? And then the next thing that we could do is, why aren't you scrolling down? All right, that will be the end of this one.